Toward, I represent you a device that check the weight of an industrial machine. It is a scale, and on top of this plate there is a bucket where items that build the items that build this machine are put. And if the weight of the items goes below or above a certain threshold that we have set inside the scale, this device, an alert is triggered, and the machine eventually gets stopped. And below this plate there are 4 chip sensors in Weston Bridge configuration. This is a prototype, but we are going to build something more industrial with better sensor. And let's see how does it work. Oh, by the way, this work with the chip sensor, but we are going to build something better. So what's on the display? We find the interval of time between each weight. There is 1 second now, and the current amount of weight. If I press here, you see the weight goes up. And if I long press the set button, we enter the setting menu. We can set the interval of time between weight, the numbers of errors that has to be triggered before the alert, the final alert is triggered, the minimum weight error threshold, and this is now set at 1 kilogram, and the maximum weight error threshold is 5 kilogram now, and the tail. In running mode we can set the tail by long pressing this button. If I put this 2 kilogram weight here, you see we have 2 kilogram, but if I long press the tail, it's 0 now. And if I long press this one, the device is powered on. We have 0 and no error, the weight is okay. If I press here and I go over 5 kilograms, we have more than 5 kilogram and errors keep going. And if I remove this, weight is below 1 kilogram and we have 5 errors, and then we reach the alert. To reset the alert, we simply long press this down. Well, in order to calibrate this device, we long press the select while powering this on, and let's long press this. And we enter the calibration mode, where we have 4 steps. The first one is the gain selection, and then is the offset, that is the tail of the scale, and the calibration weight. I have used this weight to calibrate this model, and then I have to long press this while this weight is on top of the table, the plate, to calibrate the device. And then I long press this and I save all the values. So let's set the tail to 0 and we are good to go. What's inside this? The logic is all built inside this ATmega8, and this is the IC that I've used to read the load cell values. It's an HX711, and this is the relay for the alert, the display buttons, and this is just for the programmer, is the adapter for the programmer that I'm using, and this is the DC to DC converter. It's all